oranges from what? You can say plantation, you can say orchard, or you can say up to you. And you can name the orchard as you like. Orchard, ABC. Are you clear? Oranges from this orchard. Okay, now, when you talk about when you write your folio, when you talk about in Malaysia, have you ever seen any orchard plant oranges? No. So what are the plant that we have? What are the fruits that we have in Malaysia? You can talk about durian. You can talk about whatsoever. Okay, rambutan. You can talk about mangoes. Better still, one of the famous fruit in Malaysia. Do you know what is a mangosteen or not? You know what is a mangosteen? Yeah. So all these are the things. So what you can do? Okay. So now, what is the variable about this population that we want to study about? What is the variable? Variable of interest. That means the parameter of interest. What is a variable? Variable is what? Yes. The weight of oranges. Okay. From where? Okay, I purposely name it. I told you already, in your textbook, they will not name it. Okay, now, and the question say that, and in actual fact, you definitely can't get the mean of the real situation, correct? But this question, so the weight of oranges, so we let it be W. So W, they say, is normally distributed with the mean of 130 gram and the standard deviation of 15 gram. Correct? Okay. Why the standard deviation is so big? Can you tell me why the standard deviation is so big? Why the standard deviation is so big? Yes? Why the standard deviation for this case is big? If I talk about a pack of sugar, then the standard deviation won't be so big. Why the standard deviation here is so big? Yes, faster, give me the reason. You have to when you talk about. Hello. Yes. Shawin. Why the standard deviation is so big? Yes, try. Yes, Christopher? Christopher there. Sebastian. Sebastian? Why some is very big? Yeah, okay. Yeah, so they have a big standard deviation, means the size of the oranges, some are very heavy, some are not so heavy, correct? Why? Why there is such a high variation? Because oranges can come in a lot of shape. Why oranges can come in a lot of shape and size? Okay, if you study biology, if you are a farmer, you know that the size of the oranges, okay, will depend on many factors, correct? Can you name me the factors that affect the weight of an orange produced by a tree? First, the age of the tree. Am I right? Second, the weather. If during the time they're fruiting that time and the weather is very dry, do you think the oranges will be juicy? No. Correct? Hello? And also depend on the fertilizer that they use. That will determine the size of the oranges. Correct? And also depend on the weather. The weather like I talk about. Correct? So when you are talking about this thing, correct? When you are talking about this thing for your folio, correct? Like for example, a farmer claimed that, okay, when after using a certain type of fertilizer, okay, the weight of the oranges produced, the mean weight of the oranges produced by his farm increases. So if I talk about this statement, so I have to make some assumption there. What are assumption I have to make? Because there are many other variables that determine the size of the oranges, correct? So what's the assumption I have to make when I write this? I only want to vary one. That is the fertilizer that I'm using. So I can only talk about one variable. So that means I have to write in my folio that I assume from the same trees with the same weather. Isn't it? So these are the type of assumption that you can put in. So you see, when we talk about things that change because of many other factors, correct? We just zoom into one factor and we want to make the claim, correct? We have to write down in that we assume the rest of the variable are constant. Do you get me? So that is something that I want to point out to you. Why this one have a very high standard deviation? Because there's a lot of factors that affect the weight of an orange. Types of tree. Yeah, the tree, old tree, young tree. Do you know there is a vast difference? Do you know that? Weather. Type of soil. Do you know that? Type of soil also will affect. And the fertilizer that you use. So if you want to talk about this, you write down all the factors that affects that variable that you are interested in. Hello? So that's why it have a very high standard deviation. You compare to a bag of sugar that is packed, the weight is, the variation is very small. One thing is the size of the sugar is very small and you are machine feed. So the variable is just what? There's no variable at all. It's just the size of the sugar. Am I right? So that's why the standard deviation is very small. Do you get me? That kind of thing. So depend on what topic are you talking about. So from there you have a lot of your assumption. Do you get me? So that's why I want to explain this particular question. We have done this before, correct? So I'm not going to get into it again. So I just want to point out this thing only from this example. Got it? Okay. Okay, Pastor, Ayo, I told you, population where got number one. Yes. Customers at a railway. So you can name the railway station ticket booths. Okay. Okay. And okay. So what is the variable? Or the parameter variable is Sebastian? Is time taken? Yeah, is time taken, correct? Time taken. Okay, we put it as T, to serve a customer at this place. Correct? And the question said that this is normally distributed with a mean of 45 seconds and the standard deviation of 20 seconds. Who? This standard deviation is extremely big, correct? Can you tell me why this standard deviation is very big? Yes. Why this standard? Raisa and Asian. Yes. The what? I can't get you. Yeah, why the standard deviation is so big? Half of the mean. What to do with the destination? I serve you. You come and you come and buy ticket for me. How long each customer will take? Raisa, what's up? Yeah, why? Why the standard deviation is so big? Different customer have different problem. What's our problem they have? What is my technical problem? First of all, yes, technical issue, internet issue. Internet issue can be one of them. Sometimes internet is down, so they cannot operate. Sometimes the internet is slow, they cannot operate, so internet issue. Then one more. Hello. Some customer, they are not decisive. Correct? They only when they reach the counter, only they decide what to buy. Then they ask a lot of questions. Correct? What other reason? Hey, your this class or never want to tell me reason also. Next time I keep quiet also. The other class give me all this reason. Hello, Sama? Some people talk slower, possible. Yeah. That means some people got language barrier. So they take a long time for the one who sell the ticket to understand what he or she want. So you will take a longer time to serve the person. Yes? Yes? Right? Not all. Maybe, yeah. Certain customer, they want to go for the certain trip, but it's full. So they have to make a decision of making another, buy another ticket for another trip. Yeah, so that will prolong the time to serve. Some more? Yes? Different payment method. Correct. Different payment method. Some maybe they give the big notes whereby the person who served them have to take a longer time to give the change. Possible. You see, these are something that other never give. The other class never give. You see or not? That's why I say, whatever is it, please speak up. You keep to yourself. They never tell you the sample size. Do you know what is the sample size? Is it 11? No. Why? Must be 11 plus you. You are the one who want to buy the ticket. So actually the sample size is 12. The person have to serve you also, correct? You are in the queue. There are 11 people in front of you, include you, so there are 12. So the sample size is 12. Okay, now, I want to ask you this question. Is sample size 12 large enough? No. Raisa say no. In order for this to be normally distributed, is the sample size 12 large enough for this sample mean to be normally distributed? Or if I don't want to use, because they give me the total time is total time, correct? I talk about is my S12 normally distributed? Yes? Sebastian, is this sample size large enough for some of the 12 samples to be normally distributed? No. No, but there is what are you talking about? Faster. Not large enough. Why you say not large enough? Okay. Okay, Sebastian, the rule of thumbs is only applicable if what? If the population is not normally distributed. So you don't say, you say that it doesn't matter whatever sample size is because the population is normally distributed. So sample size 12 large enough or not for this case? The answer is a yes. You see or not? The answer is a yes. If I ask you for this case, is the sample size large enough? The answer is a yes. Because the population is normally distributed. So regardless of whatever sample size, some of the samples or the sample mean distribution will be normally distributed. So you cannot say no. You have to say yes. Hey, this is the 11th time I say. Yesterday I said 10 times, now is 11 times. Okay, do you get me? Okay, so now Christopher, may I know what is the mean for the sum of the sample? I'll see there, I'm at there. Total time is 10 minutes. What is the mean of the sum of the sample? Faster, I want to go back a bit. Christopher, how can it be 45? I'm talking about S. 45 times 12. And mean of the population. Ayo. Right? And the standard deviation is square root of n times by the standard deviation of the population, correct? So this is square root of 12 times 20. So therefore, probability of S12, okay, on time. So it must be less or more than 10 minutes. Must be less lah. So it must be less than 10 minutes, but everything is in seconds, so you have to times 60. So you use normal CDF and key in everything. Are you clear? Okay. So do you get me? Okay, now. Yes, are you okay? Sure. Exam, you really have to, if not your whole paper fumble on, I tell you, you don't know which is which. I've seen students fail this test. Just give me what to divide by what, Sebastian. You don't have to calculate the value. You can key this straight into your calculator. 20 divided by square root of 12. Okay, now, so my probability of T bar 12 must be less than. So I got 10 minutes, correct? So if I equally distributed, so I have 10 times 60 divided by 12. So this is the one that I'm supposed to put in. I'm talking about sample mean. So the mean time, the average time each will have. So isn't it, I take my total time divided by 12. So you try to calculate this, see whether you get the same answer or not as just now we use S12. So both are correct, depend on how you write it. So you go into your normal CDF. So this, we are talking about average time. I mean, average time for each one. That's why we take the total time divided by 12. Normal CDF. Okay, so this is 50. Okay, negative 10 to the power 99. 50, 45, 20 over square root of 12. You key in like that. Okay, answer same, correct? So depend on what you do. Okay, it doesn't mean that always must use sum. All right, you can use both. Yes. Yeah, it doesn't matter. As long as you talk about normal CDF, if there's no lower boundary, always put negative 10 to the power 99. So that you cover everything. Yeah, understand or not? So there's this is not talking about logic. We just cover everything. Okay? So you have to be very careful. Are you talking about the total time? Are you talking about the total? Are you talking about the mean? So your variable of interest, is it the total or the mean? So look, so when you are doing your folio, correct? When you are talking about a group or a package, a pack, correct? Like every time when you talk about, okay,